Hi, hello everyone. Thanks for joining me in my today's video presentation. My name is Pravinayal. I am a student at Sri Venkateshwara College of Engineering, Bangalore, Department of Computer Science. In today's video presentation, we are going to be discussing on the topic flat plate collector. So, let's get started. What is a flat plate collector? Before getting into that, let us know what are solar thermal collectors. A solar thermal collectors are special kind of heat exchangers that transform solar radiation energy to internal energy of a transport medium. The major components of a solar system is the solar collector. What are solar collectors? Collector is a device which absorbs the incoming solar radiation, converts it into heat and transforms this heat to a fluid flowing through the collector. The solar energy thus collector is carried from the circulating fluid either directly to a hot water or space conditioning equipment or to a thermal energy storage tank from which it can be drawn for the use at night or any cloudy days. So now let us know the types of solar thermal collectors. Solar thermal collectors are either non-concentrating or concentrating. In the non-concentrating type, the solar collector area, which is the area that intercepts the solar radiation, is the same as the absorbers area, which is the area absorbing the radiation. In these types, the whole solar panel absorbs the light, whereas the concentrating collectors have a bigger interceptor than the absorber. For domestic or industrial water heating and space heating purposes, the solar thermal collectors are classified as flat plate solar collectors and evacuated tube solar collectors. So, let us first know the flat plate solar collectors. Flat plate solar collectors were developed by Hotel and Villen in the years 1950s. These are the most common type of solar collectors which are widely used for domestic household water heating and space heating where the demand of temperature is low. Flat plate collector is basically a black surface that is placed at the convenient path of a sun. Evacuated tube solar thermal collector. ETC are built to reduce convective and heat conduction loss. Each evacuated tube consists of two glass tubes. The outer tube is made up of extremely strong transparent glass that is able to withstand changing climatic condition. The inner tube is also made of glass which is coated with a special selective coating which features excellent solar heat absorption and minimal heat reflection purpose. The air is evacuated from the space between the two glasses form tubes to form a vacuum. So here is a figure that presents the evacuated tube solar thermal collector. So as we can see, here are the header pipes and this is a manifold, and as you can see there is a heat transfer fin and evacuated tubes and a heat pipe, and there is a molding frame. Now let us know the components of solar flat plate collector. They consist of a dark flat plate absorber, a transparent cover that reduces heat losses called glazing, a heat transparent fluid to remove heat from the absorber, a heat insulating backing, flow passage and enclosure. Now here is a diagram. As you can see, there is a glazing, there is an absorber plate, there is insulation, there is a black plate, there is a header and there is a risers. Now let us know more about these components. So firstly we have the absorber plate. It is usually made of copper, steel or plastic. The surface is covered with a flat black material or high absorbance. If copper or steel is used, it is possible to apply a selective coating that maximizes the absorptance of the solar energy and minimizes the radiation emitted by the plate. Next we have the flow passages. The flow passages conduct the working fluid through the collector. If the working fluid is a liquid, the flow passage is usually a tube that is attached to or it is a part of the absorber plate. If the working fluid is air, the flow passage should be below the absorber plate to maximize heat losses. Next we have the cover plate. It is used to reduce the convective and radiative heat losses from the absorber. One or more transparent covers are generally placed above the absorber plate. They usually be made from glass or plastic. Insulation. These are some materials such as fiberglass and they are placed at the back and sides of a collector to reduce the heat losses. Enclosure. The box that collect the box a box that the collector is enclosed in hands and components together protect them from weather, facilitates installations of the collector on a roof or a appropriate frame. So here is a diagram of a typical flat plate solar thermal collectors. As you can see, they have a transparent cover, they have a heat transfer medium, the absorber, the housing, and the insulation. Now let us know more about these components. What is a absorber plate or a flow passages? Copper, which is highly conductive and is a corrosive resistant, is the material for absorber plates. But because of copper is expensive, steel is also widely used. For a copper plate, 0.05 centimeters thick is with 1.25 centimeters tube spaced 15 centimeters apart in good thermal contact with the copper. The fin efficiency is better than 97%. The surface of the absorber plate determines how much of the incident solar radiation is absorbed and how much is emitted at a given temperature. Flat black paint, which is widely used as coating, has an absorbance of about 95% for incident short wave solar radiation. It is durable and easy to apply. So here is a figure of cross section of a absorber plate and flow passage of a flat plate solar collector. As you can see, there is cold fluid in and there's warm fluid out. And here the sun heats the fluid as it flows through these tubes. Now we have the cover plates. A cover plate for a collector such as should have a high transmit for solar radiation and should not deteriorate with the time. The material mostly commonly used is glass. A 0.32 centimeters thick sheet of window glass transmits 85% of solar energy at normal incidence, and all glasses is practically obtuse to long wavelength radiations and emitted by the absorber plate. Some plastic materials can be used for collectors glazing. They are cheaper and lighter than glass, and because they can be used in very thin sheets, they often have higher transmittance. However, they are not as durable as glass and they often degrade with exposure to ultraviolet radiations or high temperature. So now we have a figure of cross section of a cover part of a flat plate collector. As you can see, there's glazing, which avoids glazing, and here is a short wavelength radiation from the sun which is falling into the cover part, and the long wavelength radiation re-emitted by the absorber plate are within this. Now we have the enclosure or insulation. The collector enclosure is usually made up of steel, aluminium or fiberglass. In order to prevent heat from escaping through the back of the collector, a layer of insulation is placed behind the absorber plate. As you can see, I have displayed a table which contains the characteristics of insulation materials. Now we here are with a figure which shows the cross section of an insulation part of a flat plate collector. You can see there is an insulation placed here and there is a cross section of the collector at this area. And these are the heat absorbing materials, and here we have the glass. Now let us know the working principle of a flat plate collectors. In flat plate collectors, sunlight passes through the glazing and strikes the absorber plate, which heats up the changing solar energy to heat energy. Thus the heat is transformed to the fluid, passing through the pipes attached to the absorber plate by means of convenient heat transfer. Absorber plates are commonly painted with the selective coating which absorbs and retains heat better than ordinary black paint. Absorber plates are usually made of metal, typically copper or aluminium. Because the metal is a good heat conductor, Copper is most expensive, but it is better conductor and less prone to corrosive than aluminium. In locations with average available solar energy, plate collectors, flat plate collectors are sized approximately 1 half to 1 square foot per gallon of 1 day's hot water use. You can see there's a diagrammatic representation of working of flat plate collectors. Now let us see the figure which shows a flat plate collector solar air heater. Here there's a prephoted absorber, ambient air, and you can see the heated air comes out in this way. Now let us know the collector's performance. The thermal performance of a collector can be calculated from the first law energy balance. According to the first law of thermodynamics, for a simple flat plate collector, an instant steady state energy balance is useful energy gain QU is equal to energy absorbed by collector minus the heat loss to the surroundings. And it can be written as absorbed energy is equal to AC into FR into S, and loss energy is equal to AC into FR into UL into TI minus TA, where AC is equal to collector's area, FR is equal to heat removal factor, which is unitless, S is equal to absorbed solar radiation, which is joules per meter square, UL is equal to heat transform loss coefficient, which is joules per meter square Celsius. Ti is the mean absorber plate temperature, which is Celsius, and Ta is the ambient temperature, which is degrees Celsius. So Qu is equal to AC into FR into S minus AC into FR into UL into Ti minus Ta. Above equation is an extremely useful equation and applies to essentially all flat plate collectors. To improve the performance of a solar collector, it is necessary to either to reduce the overall energy loss coefficient or to reduce area from which energy is lost. That is, the maximum possible useful energy gain in the solar collector occurs when the whole collector is at the inlet fluid temperature, i.e., which means heat loss to the surroundings are then at a minimum. Now let us know the collector's efficiency. The basic method of measuring collector's performance is to expose the operating collector to solar radiation and measure the fluid inlet and outlet temperature and the fluid flow rate. The useful gain is Qu is equal to m dash into Cp into To minus Ti, where m dash is the fluid mass flow rate, which units are kg, kilograms per s, and Cp is the fluid specific heat, where the units are joules per kg degrees Celsius. The above equation describes the thermal performance of the collectors operating under the steady conditions can be rewritten Qu is equal to ACFR into GT tau A minus UL into Ti minus Ta. This equation gives useful gain energy, where tau A is the transmittance absorptance product that is weighed according to the proportions of beam, diffusion, and the ground reflected radiations on the collector. Now let us know the applications. Flat plate collectors are used for both domestic applications as well as the commercial applications. Let us see the domestic applications of a flat plate collector. A flat plate collector mainly used in residential building where the demand for hot water has a large impact on energy bills. This generally means a situation where a large family or a situation in which a hot water demand is excessive due to the frequent laundry washing. For instance, a family of 4 members consumes on an average of 100 liters of hot water a day at 60 degrees. Hot water of 100 liters capacity of 60 degrees Celsius approximately can be delivered by a single collector system of 2 meter square area. The solar water heating systems are generally provided with auxiliary backup in the insulated hot storage tank for rainy and heavy overcast cloudy days. Here we can see a solar flat plate collector used for heating buildings. Now for the commercial applications. Commercial applications for flat plate conductor include landroments, car washing, military laundry facilities, and eating establishments. Solar water heater systems are most likely to be cost efficient for facilities with water heating systems that are expensive to operate or with operations such as laundries or kitchen that require large quantities of hot water. And unglazed liquid collectors are commonly used for heat water for swimming pools because these collectors need not withstand high temperature. They can use they can use less expensive materials such as plastic or rubber. They cannot require freeze proofing because swimming pools are generally used only in warm weather or can be drained easily during the cold weather. So now we can see the solar flat plate collectors used for heating swimming pools. Now for the conclusion. In the conclusion, we can say that flat plate collectors which are used for water heating are long lasting and also in terms of they are cheaper than other water heating systems. However, they require large areas if high energy output is required. Also, solar energy is free. So, if we do not include the initial cost of installation and maintenance, finally, besides these, we should remember by using solar energy, we can protect the nature. With this, we come to the end of my presentation. Thank you for watching my presentation. Until the next time, thank you.